Hey everyone, it's Miss Bone here, and today we are going to extend some of our thinking from the lesson that we're doing. And we're going to start thinking about the size of fractions as we have more or less pieces in the whole or equal parts. So that might be like, wait, what does she mean by that? So of course, where do we always start our understanding? We start with pictures. So today we're going to draw some pictures. And as we're supposed to place fractions on a number line, we're going to draw some pictures and start really reasoning about the size of those fractions as we break these whole pizzas, whole cookies, whole number lines up into several equal pieces. Okay, so let me share my screen here. And you guys are working on a slide or an activity that looks a little something like this, or should look exactly like this. And you have a couple number lines on there. And there's this guy who takes his number line and he divides it into 5 equal pieces. And then, the girl divides it into 5 equal pieces. And then Scott, this other guy, he divides it into 7 equal pieces. And you have to kind of sort through who's got more whole pieces, right? So, or whole parts. So I want to extend and start you sort of thinking about what happens to the size of those fractions when you divide a whole up into equal parts. So let's go to a blank screen, and there's some guiding questions on this screen that I want you to think about as I draw these two fractions. What's happening to the equal parts or pieces when I draw more of them, when there are more of them, okay? And then start thinking about, do more pieces or less pieces make the pieces get smaller or larger? Is there a connection there? And how can you use the denominator to determine the size of the fraction? How can you use the numerator to determine the size of the fraction? So let's draw a couple. I'm not going to do number line to demonstrate this. I'm going to do what we all love, pizzas. I'm going to draw 2 pizzas here. And I am going to divide, make the denominator 2 for one of those pizzas, halves, and make the denominator 4 for the other pizza, fourths, right? Now, I want to go back to those guiding questions. What happens to the equal parts when there are more of them? So let's look at this denominator. If I'm going to divide this pizza into halves, how many equal parts is this pizza going to have? That's right, 2. 2 equal parts. Let's go make those. It's going to go right down the middle. Half goes right down the middle. And again, my drawing might not make them perfectly equal, but we don't need to do that when we're working through math, right? We want to be able to understand that 2 equal parts means right down the middle. We might look at that and go, oh, one side looks like, you want to try to be as accurate as you possibly can, but when drawing, it's never going to be perfect, right? But we do know when something's divided into halves, both of those 2 equal parts are the same size. Okay, that's what makes them equal. That's what makes them halves. Now we're going to go over here and check out this pizza. This pizza's denominator is 4 or fourths. So how many equal parts should I be dividing this pizza into? That's right, 4. So let's divide this pizza into fourths. Okay, and let's look at some of our guiding questions. What is happening to these equal parts when there are more of them? So let me change the color. Let's just take a look. Which pizza has more pieces? Which pizza has more pieces? That's right. The pizza that's divided into fourths has more pieces, right? Right. Now let's look. Do more or less of those equal parts make those pieces start getting smaller or larger? Let's do some shading. You know what? I'm going to shade in 1/2 of this pizza, and then I'm going to shade in 1/4 of this pizza. Try to notice if you can tell which piece of pizza is bigger, right? It's taking me a while to shade in this big old piece, right? Taking me a while. Okay, now let's shade in 1/4 of this pizza. I think I can tell there are so many of you out there that are starting to recognize, when we have more equal parts, what is happening to those pieces? So there are more equal parts in the pizza with fourths. They're both the same size pizza, right? The whole is the same, but there are 4 equal parts in this pizza and only 2 equal parts in this pizza. Oh my goodness. Look at these pieces. I can see it happening. You guys are going, oh my goodness. When you divide a pizza into fourths, the pieces start to get smaller. And boys and girls, something that is so important, a big, huge idea that you want to remember when you are understanding where a fraction goes on a number line, you want to remember that the more pieces there are, the smaller the pieces are going to be. Because look at this. My goodness, let me go back to red and let me take this pizza that was divided into fourths. Now I'm going to divide this pizza into eighths. Can you predict what you think is going to happen to these pieces once I'm dividing this pizza into eighths? Oh my goodness. Look at that. Now this pizza is divided into eighths, and these pieces are even smaller. And if I only shade in 1/8, go back to the shading, get my blue up here to do my shading. If I only shade in 1/8 of pizza, wow, that piece is even smaller than 1/4 and way smaller than 1/2. So let's go back to our activity and just think about where we really want to go with our thinking on this, right? Let's go back to our activity and think about Scott and Vivian dividing their whole up. One is divided into 7 pieces, the other's divided into 5. And Scott's like, mine is longer because there's 7 pieces. We really want to go back and tell Scott, let's go back to our reasoning about the size of fractions. First of all, both of their number lines are from 0 to 1. Both kids, both students have number lines or meter sticks, 1-foot sticks that go from 0 to 1. And Scott thinks he has more because he has 7 pieces. Well, boys and girls, when we reason about size, we actually know that 7 pieces is going to make our pieces smaller. Right? 7 pieces is going to make our pieces smaller. So as Scott divides his up, 1, 2, 3, 4, 5, 6, 7 pieces, 7 sevenths, and Vivian divides her into 1, 2, 3, 4, 5 pieces, 5/5. The first thing we can recognize is that they both have the same, right? If he uses his whole foot and she uses her whole foot. They both have the same. However, today, mathematicians, please get your juices going about reasoning about the size of those pieces. Because actually, the bigger the denominator gets, the smaller the pieces get. Keep practicing. I know you're going to get it. Good luck. See you later.